everyone. Welcome to Tech is Strong with Shobhit. I hope you are doing great in tech and fitness. Today, we are going to cover bit manipulation. Before that, I want to say one thing that if you want to stay motivated throughout your journey, please celebrate your small wins because small wins accumulate to become a big victory. And one more thing I want to highlight is like, please watch out the other seven episodes as well. In the videos, I not only cover the topic, I also cover the question which generally asked in Google, Microsoft, NVIDIA, Qualcomm, etc. In this episode, we are going to understand how software actually controls hardware, not conceptually, but at the level of bits, registers, and memory. If you want to write real embedded or systems code, this topic is foundational. A single line of C code can turn on a motor, enable an interrupt, or change voltage on a pin. At the lowest level, hardware does not understand variables or logic. It understands bits, zeros, or ones. Hardware does not know what an if-else is. It does not know loops or data structures. Hardware understands registers, and the registers are just a collection of bits. A hardware register is just a fixed memory address, but unlike normal memory, it is physically wired to hardware. Writing to this address changes the behavior of the chip itself. A register might be 8, 16, or 32-bit bytes. Each bit has a meaning: LED enable, timer enable, error flag, and so on. Bits are not data here, bits are features. We almost never want to overwrite an entire register. We only want to change specific bits without disturbing the rest. That's exactly why bit manipulation exists. C give us bitwise operator specifically to work at hardware level. These are not optional tool. They are how embedded software survives. Let's see how we can set a bit. So here we have given a register which names as GPIO controller. We want to set its third bit without touching any other bit. So to do that, first we need to create a mask. How I can create is we have a 1, I have left shift by 3, and then I did a OR with the GPIO control register. And that's how we can set the third bit easily. So this is the safest and most common operation in embedded C. Let's see how we can clear a bit. To do that, we need to invert the mask and end it with the register. Only the target bit is cleared. Everything else stay untouched. If we want to change the state of the bit, so we can use the JOR operator. It will toggle a bit. If it was 1, it becomes 0. If it was 0, then it becomes 1. This is commonly used for LEDs and debug signal. This is very common operation in embedded. So we have to check a bit, and first we need to check the bit, and then we have to act accordingly. So if I say the particular bit is set, then there might be the case like we need to on that particular LED. If it is not set, we don't have to on that LED. Similarly, if a particular bit is set, which means that we have to boot this device in test mode, or if it is not set, we have to put it in the secure state. So there is a many things. So this operation is also a crucial operation. To do that, it's very simple. We have to create a mask. For the bit, we need to read and do the end operation. So we see a common mistake we used to do on the slide. What I'm doing is there is a GPIO control register where I'm assigning a mask by left shifting by 3. This looks innocent, but it is dangerous. It overrides the entire register. You just enable one feature because you are setting the third bit. So third bit become 1 and everything becomes 0. So you disabled everything else. So folks, once bit manipulation clicks, driver makes sense to you, datasheet become readable, and debugging become logical instead of guesswork. So if you follow this entire video properly, then you become system engineer. So what's the difference between beginner and system engineer? Beginner asks which register to write, and system engineer asks which bit controls behavior. That mindset shift changes everything. Bits are the language of hardware. C is a translator. If you control bit correctly, you control the machine. Stay strong in tech, stay strong in life. See you in the next one. Thank you for watching.